In a digital age where almost everyone is connected through computers, smartphones, and countless items of technology, we don't often think about how this all works. How does that email from work get sent? How do you connect to that website? In this series of videos, we'll be teaching you all about networks. Hi, my name is Harry, and I'll be your guide throughout this series. We're going to order these videos in a way where it starts with you and the network hardware that you have, out to the things that are connected to the outside world and the methods they use to do so. The contents of this specific video about network hardware are useful for those taking OCR A-Level and GCSE Computer Science, but those taking the AQA specs may find this interesting to broaden their contextual knowledge. Make sure to check your specific specification to ensure that you are covering the relevant information. Of course, if you're not doing any of these courses and are just here to learn, then this is the place to be. Now, all networks require certain core elements of hardware in order to operate. All network hardware is designed to generate, transmit, and interpret electrical signals. First, we'll start small. Inside your computer, phone, laptop, tablet, or whatever you're using to watch this video will be a network interface card. This is what will be communicating with the internet connection in your house and is how your device is able to connect to the internet. Each network interface card, or NIC for short, contains what is known as a MAC address, made up of 48 bits which are represented in hexadecimal and is how your home internet knows which device to send which packets of data to. Every MAC address is completely unique and no two devices share the same one. Routers are used to connect networks together. You probably have one in your house. They'll receive data packets from one network and forward them onto the relevant device on its own network by sending those packets to a certain MAC address. Most modern routers include a wireless access point within the same casing, although sometimes you may see Wi-Fi extenders offered by network providers for large houses or businesses. These are individual wireless access points. These essentially allow devices to connect to a network wirelessly without the need for a wired connection, and are the reason that Wi-Fi works. Just like a computer uses an Ethernet cable to send and receive data to and from a router, a smartphone uses a wireless access point to send that same data to and from a router. Whilst you probably don't have one in your house, you'll probably be able to find a switch at your work or school. These are used as a central point for a bunch of computers that are connecting to the internet. So in a computer room you might have 10 computers all connected to a switch. This switch then goes to the router. Switches make use of the device's MAC address to send data to the devices, so if say computer number 4 out of 10 connected to a switch made a request to the router, then the router would come back and send that data to the specific MAC address of the computer connected to the switch that made that request. Hubs aren't seen very much nowadays as they've generally been replaced by switches. They do almost identically the same thing as a switch, although instead of sending data packets to a specific device that requested them via the use of its MAC address, hubs broadcast all data packets to all devices connected to them. The device that requested them can use them as normal, and the other devices will just ignore them. The problem with this system is that someone with malicious intent can receive packets not meant for them and can steal information from the user they are intended for using these packets. Finally, we have some cables which might be handy to recognise. There's the twisted pair cable, which is used in Ethernet cables for connecting a device's NIC to a switch, hub, or router. The fibre optic cable, which uses light to transmit data at a very high speed, and it's the reason that broadband speeds have drastically been increasing. And then there's the coaxial cable, which is a lot older and transmits data at a much slower rate. So to recap and give a small example of how these devices may work together. Bob's phone has a network card, which wirelessly connects to the nearby wireless access point. This connects to the router, which will send and receive data packets from another network and pass them back along the wireless access point through to Bob's phone. In the office that Alice works at, there are a bunch of computers, all of which have network cards connected via Ethernet to a switch. This connects to the router, which will send and receive data packets from another network and pass them back to the switch, which will forward them to the computer that requested them. Meanwhile, Steve's employer is very stingy, and since the 90s, he has never updated the office hardware. Like Alice, Steve also works in an office with a bunch of computers, all of which have network cards connected via Ethernet to a hub. This connects to the router, which will send and receive data packets from another network and pass them back to the hub, which then broadcasts those packets to all the computers which are connected to it. Unluckily for Steve, his colleague knows a bit about hacking. He intercepted the packets and was able to find out some confidential information about Steve. RIP Steve. I hope you enjoyed this video and learned a lot about different network hardware. Join us next time to continue learning about networks. For now though, please like this video if you enjoyed it, subscribe to see more content from us, and hit the bell icon to be notified of when we next upload. Don't forget to follow our Instagram and Twitter for daily posts about computer science, and join our Discord for technical support and to meet like-minded people. My name is Harry from Sapien, and I'll see you in the next one.